Good morning, students. Today we are going to see the topic electricity. So that is the most important need for our day-to-day life. See, before 150 years we don't know about electricity, but now without electricity we cannot live. See, in such a way, each and every part of our life we need power. See, what is electricity? See that nothing but flow of charge. See, charge means electrons. So we know atom consists of three elementary particles. We know what are they? Yes, they are electrons, protons and neutrons. See, these protons and neutrons already we know they are nucleons. They present inside the nucleus. But electrons they revolve around the nucleus. See, these are the charged particles. See, negatively charged particles, we know this. See, in an atom, the number of electrons are equal to number of protons. So that the atom is a neutral one. That is, number of negatively charged particles is equal to number of positively charged particles. So, an atom is a neutral one. But in the case of electricity, see these electrons, they revolve around the nucleus, no? So, they produce the charges. They flow from through a material. See, it produces electricity. See, in our lesson, we are going to see some basic concepts of electricity. So, let us see the first one, electric current. See, already I told you it is nothing but flow of charges. This flow of charges, see, when these electrons they move through a material. See, material means mostly any material, but metals are the good conductors. So through they easily allow the electrons to pass through it. So rate of flow of charges in a conductor is nothing but electric current. See, how can we define electric current? See, the electric current is defined as the rate of flow of charges through area of cross section in unit time. See, unit time means here 1 second. See, in 1 second through a area of cross section, how many electrons or how many charges are flows through it is nothing but electricity or electric current. See, its unit is ampere. See, already we have studied in the first lesson itself. It's a basic unit. The unit of electric current is ampere. Say, that is the symbol of electric current is I, we know. So, I is equal to Q by T. What is Q? Here Q represents the charge. I is equal to Q by T. See, number of charges, that is Q charges flow in T seconds, then I is equal to Q by T. The unit of charge is coulomb. Unit of charge is coulomb. See, we know this. 1 coulomb is equal to 6.25 into 10 power 18 electrons. See, 6.25 into 10 power 18 electrons when they flow, then the total charge is called 1 coulomb. So, I is equal to Q by T, where Q is charge, the symbol of charge is Q, but the unit of charge is coulomb. Then, how can we measure 1 ampere or how can we define 1 ampere? 1 ampere, if 1 coulomb of charges flow in 1 second, 1 coulomb of charges flow in 1 second, then the current flows in the material or the wire is equal to 1 ampere. So, 1 ampere is equal to 1 coulomb by 1 second. Is it clear? See, let us see a problem. A charge of 12 coulomb flows through a bulb in 5 seconds. What is the current flows the bulb? A charge of 12 coulomb flows through a bulb in 5 seconds. What is the current through the bulb? See, Q is equal to 12 coulomb, then T is equal to 5 seconds. See here, Q is equal to 12 coulomb. That means charge is 12 coulomb, then time taken to flow is 5 seconds, then I is equal to Q by T, that is 12 by 5 is equal to 2.4 ampere. Is it clear? So, I is equal to Q by T, where I is the symbol of current. Its unit is ampere. 1 ampere is defined when 1 coulomb of charge flows through 1 second. Is it clear now? Let us see the another one. See, the charges we need, it flows through a material, no? So we need a material. See, whatever it may be. See, for example, glass, mica, all the metals. See, glass and mica, they resist, they do not allow the electric charges easily. So they are bad conductors. But all the metals, they allow the current through easily pass through it. So they are good conductors. Say we need a circuit for the flow, that is we need a path for the flowing of charge, so that is called electric circuit. See, an electric circuit is a closed conducting loop or path which has a network of electrical components through which electrons are able to flow. See, an electric circuit is a closed conducting loop. See, we need a closed conducting loop. See, we know this in our household circuit and all. See, when we are switch on, just the current flows. See, switch off, the current does not flow. It means when we close the circuit, then see, we know these two terminals, positive and negative terminals. See, if they are closed, then only the charge can flow, so current passes. Otherwise, it can't. See, so we need a closed circuit. See, an electric circuit is a closed conducting loop or path which has a network of electrical components. See, what are components? Components means nothing but what are the devices or parts of the circuit. Included in the circuit is called components. See, for example, we need a battery and a key, then resistance, bulb. These are all the components of the electric circuit. So, an electric circuit is a closed conducting loop or path which has a network of electrical components through which electrons able to flow. Is it clear? See, in this, here let us see a circuit. See a circuit. In this circuit, 6 volt it's a battery, then A means it is an ammeter, then K key, a bulb and a resistance 4 ohm. See, these are all the components. What are the components in this circuit? Key, ammeter, battery, a bulb and a resistance. See, this is a closed circuit. See, when the battery plus and minus, no, so both are connected each other, then only the bulb glows, then electricity passes. That is a simple circuit. See, a closed path where the electrons can able to flow is called a circuit. See, in this picture we see a simple circuit. Is it clear? Then next important thing, electrical components. What are the electrical components? Already I know, I told you. See, the components or the parts of the circuit is called components. See, in this tabular column we have number of components. First, resistor. What is resistor? See, we normally use these components in the circuit, but we note a symbol for all the components. See, while we are drawing the circuit, we use the symbol to represent the particular component. See, for example, variable resistance or rheostat. See, in this, see the picture, see the zigzag lines and there is an arrow mark. If it is called present like this, we call it as variable resistance. So, variable resistance or rheostat is represented like zigzag lines with arrow mark or some other, see in this symbol. Like normally fixed resistor, see in the symbol used. So, where we are using fixed resistors used to fix the magnitude of the current through a circuit. Already in the circuit I show you, the same. Right. Next, ammeter. See, ammeter, the symbol of ammeter is A. See, just like in a circle we represent A, it represents the ammeter. So what is the purpose of ammeter? It is used to measure the current flows through a circuit. The purpose of ammeter is it is used to measure the current flows in a circuit, like that voltmeter. See, it is another important component. It helps to measure the potential difference. It helps to measure the potential difference. See, the symbol is V. See, in the same circle, if you represent V, it is a symbol of voltmeter. Then like galvanometer, see, if you use G, it gives or indicate the direction of the current. See, when it deflects, there is a pointer. It indicates the direction of the flow of current. Then diode. A diode has various uses. Say, nowadays we use LED bulbs, light emitting diode. Like this, in the electronic components, we have just we use diode. See, it may be studied in our higher classes. See, then like light emitting diode, LED, the symbol of LED. See, additionally two arrow marks should be there. Then ground connection. See, without making shocking or leakage of current, we use ground connections, three phases. See, near the electric board, see, where see the main switch box in our household circuit, not only in household, in all the places we have the main, no. So if there is a leakage of current, it may occur shocking. So to avoid that or prevent the circuit, we use ground connection. See, third one. So these are all some symbols of the components which are involved in the electric circuit. See, once again I repeat, resistor, see, now only zigzag, it is a fixed one. And then variable resistor, that should be an arrow mark. Ammeter, symbol A. Voltmeter, symbol V. Galvanometer, symbol G. Ammeter is used to measure the current. Voltmeter is used to measure the potential difference, and galvanometer is used to indicate the direction of current. And then a diode, light emitting diode, that is LED. Then ground connection. These are all some components which are involved in the circuit and their symbols. Is it clear now? See, next another topic, electric potential. What is electric potential? See, we know this. For example, in our houses, the water supply from the ground level water to the topmost tank, we are transferring the water with the help of a motor. Just like, why? Then only from if the tank should be at the top of the house, then only we can get the water or flow the water through each and every pipeline. See, that means that should be a pressure variation. There should be a pressure variation, that is called potential. See, the potential means, see, from the lower level to higher level, while we are moving the water, we are doing some work, with the help of motor. Just like to flow the charge also, we need potential. See, from one point to another point, against the electric force, we are shifting the charges from higher level to lower level. That is called electric potential. So see, if the levels are same, the charge cannot flow, no. So there should be a potential difference also. So these are the two important components, electric potential and electric potential difference. See, already I told you, see, for the flow of water, we need a potential difference. Like for the flow of charges, we need a potential difference. Is it clear now? See, how can we define electric potential? It is defined as the amount of work done in moving a unit positive charge from infinity to that point against electric force. See, it is defined as the amount of work done in moving. See, already I told you, the amount of work done. For why we are working? To move the charge from one point to another point against the electric force. So for that purpose, we are doing some work, that is called electric potential. It is defined as the amount of work done in moving a unit positive charge from infinity to that point against electric force. The unit of electricity is volt. See, how can we define 1 volt? Already, if 1 joule of work is done for moving 1 coulomb of charge, then the potential is equal to 1 volt. See, if 1 joule of work is done for moving 1 coulomb of charge. See in this picture, from A to B. If we move the charge from A to B, see, when they are not equal, then only we can move the charge. So, to move the charge from A to B or B to A anyway, see the positive charge from infinity to that point against electric force. It is defined as the amount of work done in moving a unit positive charge from infinity to that point against electric force. See, it is called electric potential. Its unit is volt. The symbol of electric potential is V. That may we call it as voltage. So normally we say no, voltage dropping. In our household circuits, voltage dropping. Normally in our household circuit we are giving 230 volt and mostly 23 amperes of current. So each and every household circuit in our country we have 230 volt and 23 amperes. See, it may differ according to the country. See, in our country we are using like, see, in different countries they may give different amount of voltage. Is it clear? Now next, it's already I told you, for the flow of water we need a potential difference. So there is a pressure variation like that. See, for the flow of charges also there should be a potential difference. See, if the potential of A and B are equal, there is no flow of charge. So there should be a difference. See, for example, in A 50 coulomb of charges are present, in B 30 coulombs of charges, means then from 50 to 30 the charges can move. So for the flowing of charges there should be a difference in potential. It is nothing but potential difference. See, it is defined as the amount of work done in moving a unit positive charge from one point to another point. See, it is defined as the current amount of work done. See, it is defined as the amount of work done in moving a unit positive charge from one point to another point against the electric force. See, the same unit volt is used to measure the electric potential difference also. Electric potential unit also volt. Electric potential difference is also measured with the same unit volt. See, once again I repeat, the electric potential difference is defined as the amount of work done in moving an unit positive charge from one point to another point against the electric force. So potential difference is equal to work done by charge. W by Q. Already we know this. The work done, the unit of work done is joule. So 1 joule of work is done in moving one charge, a single positive charge. So then the potential difference is equal to work done by charge, W by Q. Its unit also volt. Now see another problem. The work done in moving a charge of 10 coulomb across 2 points in a circuit is 100 joules. See, the work done is 100 joules. So how much amount of charges can flow? 10 coulomb of charges. So the work done in moving a charge of 10 coulomb across 2 points in a circuit is 100 joule. What is the potential difference between the points? See, charge is equal to 10 coulomb, work done is equal to 100 joules. So what is the formula? Potential difference V is equal to W by Q. Work done is equal to 100, then charge is equal to 10 coulomb. So 100 by 10, that is equal to 10. So in between the two ends, the potential difference should be 10 volt. Is it clear? Say B is equal to W by Q. Here the charge is 10 coulombs, then work done is 100 joule. So 100 by 10 is equal to 10 volt. No. So for the flow, the rate of flow of charge is nothing but electric current. The unit of electric current is ampere. Then it needs a material medium to flow. That it should be a closed path, that is called a electric circuit. Then there are various components present or involved in the circuit. They are called electrical components. See, in this for the flow of electric current through a circuit, we need a potential difference, then only the charge can flow. So these are all the some basic. See, and then the opposing force. See, there is a relation between the potential difference and the flow of current. See, already we know the symbol of current is I, and then the symbol of potential difference is V. So there is a relation between this V and I. See, already I told you, if there is a potential difference, then only the charge can flow. If the potential difference is high, more amount of electric current can flow. See, if the potential difference is less amount of current. So that means, see, if the potential difference increases, I increases. If potential difference decreases, I also decreases. So these are it is a relation between, that means they are in directly proportion. See, this maybe gives the help of a law known as Ohm's law. Sir George Simon Ohm proposed this law, so it is called Ohm's law. See, according to Ohm's law, at a constant temperature or temperature remains constant, a steady current flows through a circuit. Is directly proportional to the potential difference across the two ends of the circuit. See, the temperature remains constant. See, we keep temperature as a constant. A steady current, that means current I, flows through a circuit is directly proportional to the potential difference across the ends. So I by V is a constant, or I is equal to 1 by R into V. So, or we may write V is equal to IR. According to Ohm's law, V is equal to IR, or we may say V by I is a constant, that is resistance. See, we introduce a constant, proportionality constant, or here it's nothing but resistance. That is, see, how each and every material, it allows the electric charges to flow through, no, but they are not equal. See, according to the material, see, it may differ. So that we classify the conductors. Conductors means nothing but the wire is good conductors, bad conductors, and some of them insulators. See, in the plastic and the glass it won't pass, so they are insulators. But see, some conductors, all the metals are good conductors, but there are some exceptional. For example, nichrome, it is an alloy of nickel and chromium. See, it has high resistivity. High resistivity means the opposing force, that means it does not allow the electric charges, the flow of charges easily. So they are bad conductors. But there are some good conductors like aluminum, copper, iron, gold. These are all good conductors. So that the wires are made of copper, either copper or aluminum or iron, etc. Is it clear? So we use for the connecting purposes wires like made up of copper mostly, and sometimes aluminum, and are also iron wires. So these are all some good conductors. So according to the Ohm's law, at a constant temperature, a steady current flows through a circuit is directly proportional to the potential difference across its ends. Is it clear? So in this we classify the conductors, good conductors and bad conductors, no. See, in different purposes, see, if it allows, then it is called conductivity. See, it is opposed, it is called resistivity. So the R is nothing but resistance. What is called resistance? See, V by I is equal to R, no. So R is a constant, it is a called resistance. Just we summarize the things. First, what is electric current? The rate of flow of charge. Rate of flow of charge through area of cross section is called electric current. Then electric circuit. An electric circuit is a closed conducting path which has a network of electrical components through which electrons are able to flow. Then electrical components, the parts involved in the circuit are called electrical components. Example, battery, bulb, switch, etc. Then electric potential, it is defined as the amount of work done in moving a unit positive charge from infinity to that point against electric force. Its unit is volt. Then electric potential difference, it is defined as the amount of work done in moving a unit positive charge from one point to another point against the electric force. Unit also volt. See, these are all the some basic concept. See, in some other compounds, the conductivity, resistivity, and we are connecting this electric uh, resistance in series and parallel connections will be discussed in our next class. See, along with this, I give you just a link. So using that link, so there are some 10 one mark questions are given. So while we are touching the link, may open the in Google Forms a quiz like multiple choice questions. Just try to answer all the questions and submit the uh, screenshot to me particularly, or your subject teacher. Subject teacher means your physical science teacher. Okay, thank you.